Hey, what's up, everybody? Welcome back to NASA in Silicon Valley Live. If this is your first time with the show, NASA in Silicon Valley Live is a conversational show out of NASA's Ames Research Center where we talk about all the nerdy NASA news you need to know about. I'm your host today, Abby Tabor, and I have with me the extraordinary Danielle Carmichael.
Hi, everybody. I am your co-host, Danielle Carmichael, and it is great to be back. If you don't know, we are simultaneously live on Twitch, YouTube, Facebook, and Periscope. But if you want to participate in the chat and ask our guests some questions, there's only one place to do that, and that's www.twitch.tv/NASA.
Okay, so speaking of NASA news, we have a really big announcement to make today. Are you guys ready? Are you ready? Yeah. Okay, so the news is that we are returning astronauts to the moon. And this is really exciting. So we have for you today two of our experts. We're going to talk about some of the plans that NASA has for returning to the moon. So let me introduce you to Tony and Kimberly. So why don't you two tell the audience who you are, a little bit about yourselves. Kimberly?
I'm Kimberly Ennico-Smith. I'm a research astrophysicist here at NASA Ames Research Center in Silicon Valley, and I work on space missions.
Fabulous. Thanks.
I'm Tony Colaprete. I'm also here at NASA Ames Research Center. I'm a planetary scientist and work on space instruments, space missions, things like that.
All right.
Mm-hmm. I work on instruments, too.
So all things space.
We do a lot of similar stuff.
Yeah, we spend a lot of time in clean rooms, vibe chambers, thermal vac chambers, but not inside. But
not inside.
No.
You don't undergo vacuum tests. Okay.
Not on purpose, yeah.
All right, cool. So let's start with the basics of returning humans to the moon. When's this going to happen?
The clock, I think, up in front says so.
Yes, right? Yes.
So quick, do the math. in 1,656 days.
Exactly.
8 hours, 46 minutes.
To be precise,
down.
right, yeah.
That's it.
Counting in leap years.
Exactly. This is not the doomsday clock. No. This new clock of ours is counting down the days until the year 2024, which is when the first woman and the next person, perhaps it's a man, perhaps a woman, will set foot on the moon, right?
That's right.
That's right.
It's be a historic moment.
Exactly.
Yeah.
So let's talk about this mission. Let everybody know what it's called to start us off.
Well, we're calling it Artemis.
Right. Right. And who is she?
So, why Artemis? Like, what's so significant about that name?
Well, she's if you know your Greek mythology,
which I do,
or not your Latin mythology, because we are still talking Greek mythology. Artemis is the twin sister of Apollo.
That is
and
only appropriate.
Yeah, see the connection? Very smart.
For those who know about the Apollo program, that's when we did send the first humans to set foot on the moon.
Right.
Exactly. So the next are going under the Artemis mission. And I might add that when I was in 5th grade, we did Greek mythology, and my goddess was Artemis.
No way.
I'm pretty sure that played into the choice of the name for the missions.
And she's also
Abby,
a Greek goddess.
Your destiny.
It was.
That's right. That's right.
Yeah.
I'm very excited for this. So why the moon? What is so exciting for a couple of scientists about going back to the moon?
Oh boy, where to start? The moon is a spectacular place. It's our nearest neighbor. It's a treasure trove of science, of exploration. It's a place where we can learn about the history of the Earth, the inner solar system. It's also really a launching pad in terms of our exploration beyond Earth. Yeah. There's resources there we can utilize to explore, but there's also just the opportunity to test our abilities, our technologies, our processes for extended missions beyond the moon to Mars, for example. That's the ultimate destination beyond the moon right now, but even beyond that to asteroids and other places.
Wow.
So it's a huge sandbox, if you will, to really learn in and demonstrate what we can do to explore.
Yeah, well said.
Yeah, and also looking at just the moon itself, we know a lot about it, but we've not really visited a fraction of the surface or even the environment of the moon. Okay. So there's a lot of mysteries still yet to be uncovered.
Yeah.
Just on the surface and underneath the surface.
Okay.
And yeah, absolutely. And, mentioned the Apollo program. We've been there robotically. We have a robot spacecraft orbiting it now, but we've only barely scratched the surface in terms of the amount of area we've explored on the moon. There's so much more to learn.
Imagine. Awesome. All right. So you were anxiously anticipating
Very.
1,656 days from now. You'll be watching that clock closely, I guess.
Yes.
All right. So tell us a little bit more specifically. Where are we sending astronauts in 2024?
Well, this is what I was going to actually just say was what's really, really exciting is we are going where we've never been before, and that's to one of the poles of the moon, and very specifically the south pole of the moon, which is my favorite pole.
It is.
If you have to have a favorite pole, that's my favorite pole.
Well, who doesn't?
Yeah, right, exactly. And it's an incredible place, and we can talk about that as we go, but it's full of spectacular topography, moving shadows, extreme temperatures. It's unlike anywhere we've ever visited before
so cool.
in the solar system.
And we are going to talk all about that later. I'm excited for that. But you mentioned resources. Now, there's water there, isn't there?
Yes.
Yes, do you
Yes.
confirm
Yes.
true statement. Okay, so why is that so important? Obviously, I know humans need water to survive, but what do you see us using that for? Lots of other purposes, right?
Yeah. Well, water is key. Water is so important for two different reasons. One, it's incredibly scientifically interesting. And understanding the water that we now know exists on the moon is really important to understanding the processes that have acted on the moon and the Earth over the last several billion years.
Oh, wow.
Yeah, and I like to think of the ice at the poles as almost like ice cores here on Earth. If we can examine that water ice, we can actually look back into the history of the solar system. But also, just as important, it is a valuable resource. And as we probably all know, water contains two hydrogen and an oxygen atom. And hydrogen and oxygen are exactly the ingredients that go into rocket fuel. And rather than spending lots of rocket fuel to bring rocket fuel into space, which is what we do now,
Right.
it'd be great if we could actually find a resource and produce rocket fuel outside the gravity well of Earth. That would not only make things more affordable, it actually could be enabling of new architectures for exploring Mars and beyond.
Yeah, wow.
And then the oxygen in itself is what we breathe.
Yeah, of course, yeah.
And the techniques and the approach to how we excavate water on the moon is applicable to even doing it on Mars. So if you're looking for long-term human presence on other worlds and truly becoming interplanetary species, we can be creating the oxygen that we breathe and the habitats in which we're living in off-world.
Wow. That's so amazing that we're actually talking about that, as a future reality, not just a plot line in the story. Right? That's so exciting.
Yeah.
So I actually have a couple of shout outs. So Super Snail says that the Earth and Moon shirt is awesome.
Nice.
And also Space
So
TV
cute.
Net said it's great to see Tony and Kimberly again.
Yay!
Fans.
Long time fan.
Some fans.
Outstanding.
Wow.
All right. Do you have any questions yet, Danielle, or should we?
I do. So Moon Strites wants to know, what's the end long-term goal of the Artemis mission? Because we've been talking it up, but
Yeah, that's a great question. You want to take that? Yeah.
So Artemis is a term to describe a whole series of missions to the lunar surface and using an orbital tugboat interplanetary spaceship called the Gateway. It's a big architecture. But in the long term, opening it up with many partners along on this journey, we have a sustainable presence on the moon where we are, providing the infrastructure for us to stay there. For building materials, to creating the rocket fuel, to exploring areas that we've never been before, actually going into the depths of craters that we haven't explored yet, and pieces of the moon we don't see, so that long-term presence on the moon. But while we're using those techniques, those become applicable to that next step. We're living off Earth on another world in a harsh environment, and learning to deal with those challenges and solving those challenges. And once we've got that under our belt and we've understood our neighborhood background, our backyard, we can take that easily to Mars.
Yeah.
So cool. I see lots of other great questions, but I know that some of them we're going to answer
Yes.
in the next few minutes. So let's keep going. I just want to touch back on the water a little bit. How much are we actually talking about? I know you two have worked together on a past mission that found some water at the South Pole of the Moon. Can you tell us a little bit about that?
Launched 10 years ago yesterday.
Yesterday! Happy anniversary!
Thank you. And the mission we launched with, LRO, the Lunar Reconnaissance Orbiter, is still in orbit around the moon, still collecting data and making fantastic maps of the lunar surface, which actually was really enabling of Artemis. It's what's making it able to go forward.
Awesome, yeah.
Yeah, so Kim and I were both part of the LCROSS mission, which was a mission that crashed a spent upper stage of a rocket into a permanently shadowed crater at the South Pole of the Moon.
Right.
And the purpose was to understand the nature of hydrogen we had measured there prior with a different mission and saw an excess of this hydrogen. We didn't know if the hydrogen was water or just solar protons, which is hydrogen atoms trapped in the soil or what. And our job was to actually understand it, to see if it could potentially be a resource. So it was a very targeted mission.
See what that water was
So
all
I
about.
actually want to back up a little bit. Like, what is a permanently shadowed crater?
Good question.
Doesn't everybody know what a permanent shadow is?
Well, with the tilt of the moon and the illumination of the sun, there are places at both poles of the moon where the extreme topography, the rims of the craters of the moon, the sun does not get above those rims. So the basins of those craters are in permanent shadow, and they have been in permanent shadow for 4 billion years.
Wow.
And being in the shadows, if you're out in a hot day and you go underneath the shadow of a tree, you'll notice that things get a little cooler. Well, and if you're in a permanently shadowed place on the moon, things get really, really cold. So what was interesting about Tony was mentioning this orbiter mission that had found hydrogen. It was concentrated at the poles, and there was a correlation with the permanently shadowed craters. So there was this connection between lots of amounts of hydrogen in very cold places that had never seen sunlight.
And actually, it was theorized that these craters would have cold bottoms and could hold water as early as 1961.
Oh, really?
When we first were really understanding the topography, even before the Apollo program really got, off and running.
Wow.
And so it wasn't, though, until 10 years ago we verified the form of that hydrogen in one of these cold craters as water ice.
Wow. Yeah. So let's review now. That was LCROSS, which is the Lunar
Crater Observation and Sensing Satellite.
Yes. Okay. All right. Okay.
And we hit a crater at the lunar South Pole. That's why the South Pole is Tony's favorite.
Right. Okay. And where the future astronauts will be landing.
Exactly.
Right. Okay.
Yeah.
And do you remember how much water LCROSS saw?
Yeah,
Or give us an idea how much
LCROSS was
is
a
there.
point measurement, right? It made a crater about 35 meters across, half a football field or so across. And so, pretty big hole. But
We'll never see it. It's in the dark.
Yeah. We took pictures of it.
I know.
We saw it.
We saw it with that thermal camera.
Yes. But it brought ejecta up into sunlight so we could examine it. And as Kim said,
Through the soil up. When
through
it
the soil
smashed into
up,
the surface.
out of shadow until eventually reaches sunlight. And I always like to think about that soil hadn't seen sunlight in billions of years.
That's
potentially.
crazy.
Yeah. And in just the dirt we threw up into the cloud, or into the sun, sorry, we saw about 152 gallons of water.
Okay.
And if you take that measurement and all the other measurements we have of hydrogen at the poles and make some assumptions about how it's distributed with depth, we're talking 10 million, potentially up to 100 million metric tons.
Oh, wow.
Of water ice.
It's a lot of water ice.
It's a lot.
I think so.
It would make a big ice
Sounds like
cube. I think Kim and I were
ice
talking
cube.
beforehand, and it was about
130 meters.
130
Sounds
meter on a
like
side ice cube.
Yeah, like a football stadium. Football stadium size.
Ice
what you
cube
were
for the 10
calculating.
million. Yeah. It's an important science there.
Oh, it is.
How big of an ice
Size
cube
of
is that?
the moon's ice cube. And to be clear, none of this is flowing liquid water. This is crystals
All
of
ice.
frozen ice,
The
right?
temperatures are about minus 200 and to minus 240 or so below 0 centigrade.
Okay.
And this was the first time we ever sampled the bottom of a permanently shadowed crater. I mean, since then, the experiment has been repeated.
Okay, so that's the
and
only time?
not only did we find water, but there was a bunch of other things that were excavated as well.
Oh,
we found gold, mercury, argon, carbon monoxide, and so it's opening up these questions. When we're going to have humans and robots going to the poles of the south pole of the moon, we're going to get the boots on ground, the wheels on ground, and really understand what's there, because we've never been there before. We just have this, simple impactor experiment that opened more questions than it answered. But it answered one particular one.
Right.
The hydrogen is definitely in the form of water ice, and enough such that there is the resources to enable the exploration.
Exciting.
Yeah, another good way to put it in perspective is L-Cross about 5% by weight water in the regolith, in the dirt. Regolith is lunar dirt. For comparison, that's about what you have in the Sahara.
Yeah.
Oh, okay.
Yeah, just give you a feel
So
for
the
it.
wettest places on the moon is as wet as the driest places on Earth.
Okay. But
That says something. It's the
making
moon.
a comparison
It's
to
going
the
out
Earth.
loud.
But if you think about it, that's the engineering challenge ahead that we will solve to excavate it, because we know it's there. And we can extract, water has been extracted from very dry places.
Okay,
Yeah.
yes, yeah. That can be done.
It can be.
And we will do it. How exciting. Awesome. So I want to know then what's next. Okay, we know that people will get there. We're going to send people there. Let's talk about how. So what's the rocket that's going to take people on the Artemis missions to the moon? Who wants to take that?
Space Launch System.
That's it, the
I think-
SLS.
Yeah, we have an animation, I
Yeah.
think, of it, too.
That's right. Yes.
There it is. Largest rocket ever built. It's to bring humans not only to the moon, but actually beyond, too. It carries them in a capsule that's on the very tip of that just went past the frame, called the Orion capsule. Very small capsule up there. But that capsule, you'll see in a little bit here.
We have an animation for that after the
Yeah,
SLS.
it is.
but-
It is very powerful. In fact, it is designed to take an incredible amount of material to, deep space.
Okay.
So it is servicing Moon and Mars and also elsewhere. I mean, it also has amazing commercial spin-offs as well, because you can actually put up replacements of, say, the GPS satellites in a single SLS launch
Right.
rocket. It has a huge
It is a
capacity.
big,
And it could
big rocket.
transform the way we do other types of things in the agency. So it's one of many uses of a large rocket that's been, can be utilized.
How awesome.
Pretty awesome.
Yeah, it is.
Danielle, you jump in whenever you have to with a question, but otherwise we're going to keep talking about. So that was SLS, the rocket, and Tony pointed out
mentioned
the
the
capsule.
Orion on top.
So let's see the Orion capsule animation and tell us a little bit about.
So Orion is there. It is the capsule that will bring the astronauts wherever they're going to go, and this indeed can go not just to the moon but also beyond to Mars. And after a lot of analysis and study, it was eventually concluded that the Apollo shape, the blunt nose reentry system that Apollo used, is still the best way to go forward. However, look how roomy, if you're looking at this video, look how roomy this one is compared to the Apollo
Is it really?
capsules.
Yeah.
If anyone's seen the Apollo 11 documentary that's out in the movie theaters, you get a feel for how tight Apollo is.
This sits
yeah.
4, and it's a lot more powerful in every single way, from information systems, guidance, payload, everything, and it's meant to be able to carry humans longer distance, way beyond the moon.
Okay.
So it really is Apollo on steroids, I like to say. Yeah.
That's awesome. I love that it's kept some of the same design as Apollo. Way to go, Apollo engineers.
So they
You
solved some
knew what you were doing.
they solved some pretty tough challenges and they made it happen. So because we know we can do this. And
So
they
I actually
pulled
have a
those in.
question from Digital Donger. He wants to know, are you using specifically any Apollo era research or tech on the quest to return back to the moon?
Well, the shape that I just mentioned was derived originally through the Apollo program. The shape of that capsule is very critical to enabling the reentry. And this capsule is meant to reenter, parachute, and splash down in the ocean just like the Apollo program did.
And speaking of reentry, here at NASA Ames, we develop and test the thermal reentry materials. And for the Apollo program, it was a chemical compound called Avcoat. And
These are
in
for heat shields,
the
right?
heat shields, for the heat shields, for that re-entry through the atmosphere, and they would ablate, so they would absorb the heat and then, protect the capsule so as to safely return. To preparation for Orion, engineers looked at AVCOAT and modified the chemistry of that and did a lot of the testing. So there's a direct connection, even with the materials that were used during Apollo.
Pretty cool.
And just modified for the shape of the capsule, but to support even re-entry from further destinations.
Yeah.
Say you're coming back from an asteroid, or say you're coming back from Mars orbit or something like that.
Speeds can be higher.
Speeds
so,
could be different.
yeah.
So it's smarter
Yeah.
all around.
I love that. Excellent. And I love these Apollo connections. But then on the flip side, is the Artemis program different from Apollo?
You want to take this?
Oh, sure. An element that that I mentioned briefly. Sorry about the spoilers. Is is actually one of the cooler parts of the Artemis program. It's this object called the Gateway.
Okay.
And the Gateway is our first interplanetary spaceship. And this is something that NASA has never really built before. Mm-hmm. And that's why, in a sense, it's exciting. I mean, this space module, sometimes we call it spaceship, will be in lunar orbit. And it will provide the way to access all different parts of the moon. Mm-hmm. It's also going to be crewed, but not 100% of the time.
All right.
So it has to be autonomous. So it'll have a lot of autonomy in it. And it also would be providing a way to be a space laboratory, so we can put experiments on board for understanding biology outside our magnetosphere. It also can dock with all the different commercial and international partners. It has an open architecture. Right. Okay. The port designs are going to be available for anyone who wants to build things that connect to it. Okay. The Orion will connect to it. Landers will connect to it. Service modules, but it has the ability to change its orbit, so it can also become this interplanetary tugboat. Because it can move things around and first enable travel. I mean, it's the transportation backbone for Mars exploration.
Oh, wow. Okay. And again, this is Gateway, right?
This is Gateway. It's called Gateway.
Yeah.
And we're going to, this space ship and we have an animation showing of this orbit in which the Gateway for the lunar exploration will have, really is enabling. And this is the part of the Artemis program that's Apollo didn't do this. Apollo took everything with them and everything came back. So Artemis is building up a sustainable presence. Right. And this Gateway is key to that.
Yeah, and one part that I'd like to emphasize that Kim mentioned that is really different from Apollo is this open architecture aspect. Yeah. Is NASA's not doing this alone, and it's even beyond what we did for the International Space Station, where we had lots of other government agencies involved. There is a huge involvement from the private commercial sector that's involved in all parts of this. Mm-hmm. So this Artemis program and lunar exploration going forward has got a commercial element, a private sector commercial element. A lot of people call it new space. Part of it that didn't exist during Apollo.
I see,
so we are really, I think, at the dawn of a new age of exploration in space beyond LEO.
And
low Earth orbit.
Low Earth orbit. Sorry.
Going farther out. Yeah.
And also, as Tony was saying about this, it's sort of a space economy. You have a lot of partners. Mm-hmm. We're on the verge of, if you were to go back in time and ask the Wright brothers to look at modern day today and see that, I can fly from place to place on this planet using an airplane that they did this, or go back and talk to Alexander Graham Bell, who invented the telephone, and we all look at using our smartphones to communicate. We have no clue what the future of space will be when we involve the commercial aspect of it.
Oh, wow.
It is really unbounded future.
Wow.
Yes.
That's monumental.
Yeah.
How exciting.
This is why it's different than Apollo.
Right. If you ask a simple question, you get a big answer.
Pretty profound answer.
Yeah.
Right?
And from the science point of view, Tony and I are real excited about the science, but it has a lot of, it's much bigger than the science.
And it'll enable a lot of that science, and we'll be able to do things we could never have done
before.
Yeah.
Wow.
Okay.
Well, How long? 1,656 days.
Well, let's move into our rapid fire section. So I'm not going to give any usernames, but I'm just going to go ahead and just spit out some questions.
Rapidly fire questions.
And we have to rapidly
First
answer.
one.
Yes.
What is the long-term effect of the human body on the moon?
Long-term effect of the human body on the moon or the environment on the human body?
Oh, I understand the environment on the human body.
So it goes both ways, though, and that's
true.
actually a really interesting question from the science standpoint in particular. These cold areas, these in the craters are what are called cold traps. They're so cold, any molecules that get in there freeze out. So every time we've gone to the moon and the astronauts vented water or vented other things or outgassed means stuff subliming off of equipment, those molecules, some of those molecules very likely found their ways to the poles of the moon and froze out. And they're there now forever until a meteorite might release them. If we go, once we go exploring, not just we, NASA, but the world, we'll bring more and more of these volatiles and other materials to the moon that will be trapped in the cold trap. So if you're trying to understand some pristine environments to understand the history, the last 3 billion years, you want to do it in a way that you can understand what contaminants you've brought there yourself.
Yes.
And we NASA Ames, flew a mission not long ago called LADEE, the Lunar Atmospheric Dust Environment Explorer, and its principal purpose was actually to understand the lunar atmosphere, the exosphere, in its pristine state, with the anticipation that more and more countries and commercial peoples would be going to the moon. And so we wanted to get kind of a background before we started impacting the moon.
Right, yeah. The baseline before we touched it.
Right,
Yeah,
right.
Interesting.
From a impact on the human body, radiation is one of the principal concerns, and there's a lot of very clever solutions being looked at in terms of shielding. And we talk about water as a resource. There's lots of other resources at the moon, and especially at the poles, including lighting for solar power, but also the dirt itself. The regolith can be an excellent insulator.
Oh, okay.
And so, as Kimberly was talking about, living off the land involves using whatever you have, whatever you have on hand
no
to
choice.
make your situation better.
Yeah. Excellent.
Okay, next question. How many launches until the first base is set up?
That's a good question.
Well, we're not concerned about a base. So there's 2 phases to the Artemis. The one is the return of the first humans, and that's the 2024 milestone. And then there's a later milestone, 2028, where we have a more established presence there. Prior to the first humans going on the moon, we'll have the first launch of Artemis 1, which will not have humans on board, but will carry space satellites and robots and the like. Some will go to deep space. A second Artemis mission will actually go to the moon or in orbit around the moon. It's on that third launch of the SLS that we would be carrying the humans. And that's the 2024 milestone. So we should see a sequence of incremental steps towards proving out the new launch system and the new capabilities. In addition, the first module of the Gateway, which is the solar propulsion element, which is a really cool technology advancement. We've never seen an engine like this on a spaceship before. That's going to be launched by a commercial rocket. And so that's, we're going to be having all these different types of infrastructures getting us all part of the Artemis program.
And that's it. This really brings up an important point. It's not it will be done by this date. It will be a continuous development and build up of to reach an eventual sustained presence. And so the exact date when it becomes a base or whatever you want to call it isn't
Moon Village.
Moon Village,
Moon City.
Moon Town, community on the moon. When that exactly happens is kind of ill-defined because it's really building up of capabilities over time. There will be longer and longer stays as they move through these various phases, as Kimberly mentioned, for the astronauts on the surface. So.
Okay, so we have time for 2 short questions, I hope. So how long is this gateway going to be inhabited by astronauts when it's finished?
That's a good question. I mean, it's variable. The key point is that spaceship needs to be able to operate without humans because there will be periods in which humans aren't on board. So I don't know the exact fraction of it, but it's going to have 2 different modes, when the humans are on board and when they're not.
Yeah, I've heard numbers up to 30 days at a time.
Okay.
So they're not going to be up there for a year like we do on space station. They'll go up there and then come back in a month or 2. And so that's to Kimberly's point is a lot of the time you'll have to have robots running the house.
Okay, so last question. Someone wants to know, like, what's the coolest thing about Gateway?
I've heard you vote for this power.
Well, I agree with Kimberly.
element.
I call it the tugboat. It's this electric propulsion system, and it's at a power level we've never built before.
Really?
And what's neat is it allows it to change its orbit around the moon. So it is really a spaceship. It's not just going in an orbit. It can actually steer this entire space station size kind of thing in space.
Okay.
And then ultimately, it's the kind of engine that's going to be used to bring us to Mars and to asteroids and to wherever else. So, it's a slow ride. It's slow acceleration.
Yeah.
The acceleration, it is slow, but it's powerful. It allows you to get to the kinds of velocities with a lot of mass that you need to do interplanetary travel.
Okay.
And I like the open architecture, 'cause I don't think
that's new.
all the engineers have figured out all the wonderful uses of Gateway.
Not yet.
Because it's a little, it's going to be designed for a certain purpose and will achieve those purposes, allowing the docking of multiple vehicles from different countries and companies, allowing astronauts to stay for periods of days, months, being in constant communication with the Earth, being in communication with the surface of the moon, being able to deliver things to the surface of the moon at different latitudes. It's very versatile. But it could also be a test bed for testing other types of vehicles that actually might be made in space someday, and then launch them from there. It has a lifetime that will keep giving. Okay. We're only thinking about how to, do that first step is the first step in the return to the moon, the forward to the moon part. But there's a lot more than it can give.
Yeah.
Okay. Yeah. You both keep mentioning learning at the moon, and then we'll go on, and SLS could take us to Mars. So let's talk really quickly a little bit about Mars. So what are some favorite fun facts about Mars that you can share with us?
Okay, well, we have a picture of Mars to cue people in what Mars looks like.
Yeah.
It's the fourth planet around the sun. It's a red planet. The red is primarily due to iron in the rocks on the surface of Mars. Mars has polar caps. It has, it's one of the other bodies besides the Earth that has frozen ice. It's water ice and carbon dioxide ice at the poles. Cool. It has an atmosphere. But its atmosphere is different than Earth's. It's probably made of carbon dioxide, whereas our atmosphere is nitrogen-based. Where the Earth is the third planet and Mars is the fourth planet, we're both circling around the sun. If you imagine cars on a racetrack.
Yeah.
So at our closest distance between the Earth and Mars is about 34 million miles, and that happens every 26 months. Otherwise, we're doing laps.
Right, they're moving at different speeds around the racetrack.
Around the racetrack.
Yeah.
So this is a reason why when we launch our, robots to Mars, and in the future, the crewed missions to Mars, taking advantage of that 26-month period of alignment helps shorten the distance, because even at that shortest distance, the trip is still about 6 to 9 months.
Yeah.
Okay.
Still a long way to get to Mars.
You want to take advantage of that.
Yeah.
Excellent. All right. And the moon, you say, is going to help us practice for what we might do when we reach Mars,
everything we so much of what we will be doing on the moon is extensible to Mars, and everything from the kinds of tools we use to the procedures and processes and the technologies, learning to really work and build and construct in different environments that the moon and Mars, everything from gravity to little to no atmosphere, etc. It's really important. And bring it back to water, as Kimberly mentioned, Mars has got water. We've known that for a while. It's got a lot more water than the moon.
Okay.
But that is one of the key connections between the moon and Mars, is as we learn to utilize water on the moon, everything from locating it, excavating it, processing it, all that can be carried over and applied to how we do that on Mars, which we want to do. We want to, live off the land at Mars too. We don't want to bring everything with us to Mars eventually. We will, of course, the first few times, but you can't. It's too far away. Yeah.
All right.
And let's just say, I was mentioning earlier, is once we're really comfortable with this whole approach on excavating the water and processing the water and transferring it to rocket fuel or oxygen or other utilizations, because water can be used in many different ways. That's a totally applicable system for Mars. Directly. And also, most likely, there'll be wonderful spin-offs that can be used back here on Earth.
Oh, yeah.
I mean,
those are
anything
always
to do with
great
things in a
stories.
closed system is usually very power conscious. You're not using a lot of energy.
Yeah, recycling a lot of stuff.
Recycling a lot of
Recycling,
things.
yep.
We'll have, very improved technology.
Awesome.
That, who knows what we're going to
Actually,
discover.
I have a question from the chat. Looks like King Goldboy Gamer wants to know, like, when are we actually going to go to Mars?
I don't know if you guys know
I don't know.
precise
I don't
date.
know the precise date off
Yeah.
the top of my head, but it would be, a couple decades beyond.
Okay. It's still a little ways out. So first, we're
Still
going to the
around.
moon. We're going to practice. We're going to learn to excavate water and process it and all that.
And also, the most fragile part in this whole amazing exploration adventure is the
Yeah.
human body.
Wow.
The human body outside the magnetosphere, we've had only 24 individuals who've been outside that. We are now going to have the ability to really study biology and how the human body is reacting to this. This will make us totally prepared for that long trip to Mars. Because a mission to the moon is 3 days, and you're on the surface for weeks, months, come back, but you're close to home. When you go to Mars, we're talking a 2-year. And how is the body,
2-year trip.
it's like a 6 months, 9 months to get there. You're going to be there for a few months and you come back. You want to take advantage of the close by, so you're going to be on a sort of a 2-year time scale.
Right.
Just think
Travel
about
that
it.
way.
What we're going to learn to protect the human body and, enable all the infrastructure to allow the human body to survive and thrive, we'll solve that by being on the moon.
Yeah. Cool.
And-
So tell me quickly. So I want to know what's coming up then. What's in the news coming up next in the process. So human landers will be built by NASA, by partners. What do you guys know about that?
I believe there was a bid that went out on the street for companies to provide lunar landers and docking with the Gateway or not, because it's a different type of architecture you can use. But yeah.
Okay.
Yeah,
All
and
right.
there's a variety of landers being pursued with the commercial sector with NASA, and there are smaller landers being built now, and we've actually NASA just recently selected 3 to be carrying NASA payloads.
So instruments and things
Instruments
before
and things.
people go.
Exactly.
Yeah, they would land
And-
next year.
Yeah.
Next year already.
As soon
Yeah.
as next year,
Whoa.
Yeah.
and a couple in the summer of 2021. And what's really neat is these companies are providing NASA a delivery surface. It's not NASA telling them we need a lander like this.
No.
It's they're building a lander that provides a service and selling that service then
Okay.
to NASA. Here's an example of one on the screen of one of these small commercial landers. And these companies then have plans to increase the scale and the scope of these landers so they can carry more and more to the surface. So the human landers are, like as Kimberly said, right now being discussed with commercial companies as to who's going to participate and build them going forward. Okay. And it's really kind of exciting because, again, this is a totally new paradigm. NASA's always built the landers with commercial companies, but they've done it in a very much requirement-driven process. We need you to build this for us.
Okay,
Right?
I see. Yeah.
This is very different. This is I'm buying my airline ticket to fly across the country. I'm not telling you how to build your airplane.
Right. You
That's-
get me there somehow.
Exactly, and that's what we're doing now.
And other folks can pay to use the services. So it's
Not
it
just
opens
NASA.
up the
Yeah.
of accessibility of the moon to.
Okay. So
Okay.
anybody conceive? Oh, sorry. you have a
No,
question?
it's okay. I have a question from the chat. Space TV Net wants to know: are any of these vehicles going to be like the lunar roving vehicle?
Yeah, there's actually commercial rovers actually being discussed too. So NASA's working on some rovers as well, but
And rovers come in all shapes and sizes.
exactly,
They do?
yep, robotic, but also for the humans beyond 2024. there's definitely plans for large, even pressurized rovers that they would go in. So
I see.
way beyond what we did in the Apollo era.
Think the Martian, remember? Even the
Okay.
pressurized.
So, but some of these commercial landers, the ones going in the next year and a half or so, are carrying very small rovers, 5 kilogram, 10 kilogram rovers.
tiny.
And eventually
pounds.
those rovers will be also providing a service. So the landers provide the landed service, and commercial rovers can provide a roving service.
Cool.
Okay.
So I can put my instrument on a rover that we can buy space on, rather than NASA having to build all that.
Okay. Now, speaking of your instrument, I know that you have a
Was that a
lunar.
good segue?
That was perfect. Thanks, Tony. Did you bring it today?
Well, I brought part of it.
All right. Can you
Okay.
show us and tell us what it's going to do up there?
I don't drop it. That
So
would be
something
bad.
like this is flying to the moon in the next year or two?
Yeah, so this was selected to fly on one of the 3 landers that is going to the moon in the next couple of years.
Nice.
And this is it's called NERVIS.
Nervous.
It's a terrible acronym. I know.
It is, of course, an acronym.
It's an acronym.
What does it
And-
stand for?
Near infrared volatile spectrometer system.
Okay.
And what it does is it finds water. That's its principal purpose, is to find volatiles, but especially water.
Okay.
So it's a prospecting instrument. If you think about when we look for minerals and resources on Earth, you prospect, you go and look at, this is what this instrument's meant
Yeah.
to do. Yeah.
Sniffing out where the water is.
Exactly. And this is an engineering unit. This is a unit that we use to develop the technology, make sure we can make the measurements and meet the goals we want to meet. And then we then test it in the similar environments it's going to see. For example, it has to survive launch, landing,
Oh, yeah.
vacuum, radiation, etc.
You test all that,
And
yeah.
you test all that, make sure it works, and you can see it's just got a bunch of eyes on it.
Yeah, I was going to ask,
What are
what
those
all's going
eyes?
on there?
Yeah. So what it's meant to, an important aspect of this is it needs to work both in sunlight and in darkness. Just like Kimberly was saying, these are dark craters. We're really
Right.
interested
Yeah,
in
because
going
there's that
really dark craters.
correlation, but
We have to go down there and we have to look at the scales we're going to
Yeah, it's the
work
scale.
at.
Okay.
Because the data from orbit is giving us hundreds of meter kind of footprints of where the
the
water
resolution,
is.
yeah.
This is going to give us human scale, things
Right.
on the meter, and that's an unknown. So we do need to.
Exactly.
That's exciting.
This is a.
So real quick, this little guy right here, I can't get the nice blue shine of it. This is an infrared lamp.
Oh, yeah.
And the intent of this is to actually provide infrared light for the other instruments so it can see in the dark. Likewise, all these things over here, these little guys, those are LEDs of various colors. So they provide illumination from the ultraviolet to the near infrared. For our camera system, which is right here, this is a lens to the camera system, this black thing. This allows us to image the area at very high resolution, understand the chemical makeup, the mineralogy, the morphology, and things like that. And the last thing are the 4 sensors right underneath the camera. These 4 right here. This is really hard to do. It's like doing it in a mirror. Those 4 there, those are thermal sensors. It's a thermal radiometer. And what that does is it allows us to measure temperatures of the scene we're looking at, because we're interested in not only understanding if water's there, but we want to understand the environment we are finding water or not finding water, because ultimately we will use this data to build what is called a resource map. On Earth we call them a mineral map. It's what the United States Geological Survey provides to a company that's interested in finding minerals. And we're going to do this on the moon. Basically build these maps and understand the location. This is one instrument of several that is dedicated to do this kind of work.
Oh, yeah. All working in tandem and
Yeah,
piece together a map together, maybe.
Yep.
Yeah.
Exactly.
I see.
Yeah,
That
yeah.
makes sense.
And I'm trying to convince Tony that the next iteration of this is to be handheld by the astronauts.
Ooh,
so we can
yes.
have the astronauts go and look at it and like, okay, time to go. That's our resource.
Yeah.
Sold. I'm
That's what I'm
it.
working on next.
Let's do it.
It's on. All right. Do you have a question
Actually,
right
I
now?
do. So, Gar Chose wants to know, how is NASA going to protect these rovers from lunar dust?
Yeah, lunar dust is a unique beast.
It is a beast.
Yes.
And it really is unique in that it's only generated because of the environment on the moon. It's generated through the impact processes. And so the dust, and it's never eroded. There's no air.
There's no wind to make or water or flowing liquid water to smooth things
Yes.
out. So
Yeah,
it's
yeah.
jagged and
jagged. It locks in place.
It's like glass. And the Apollo
wild.
astronauts, complained about, it got into their lungs and it scratched their suits. The suits were all ripped to shreds.
Wow.
So it is a beast.
It is
A
beast.
unique beast.
And the way you protect, there's a lot of ways you can protect it. Everything from electrostatic barriers they're working on. So one nice thing about a lot of the lunar dust is it has a magnetic property to it. It's got some ferric iron in it, nanophase iron, and so you can actually repulse it with electric fields. You can also develop force fields.
Force fields,
Exactly.
like Star Trek.
Yeah. And also a number of other mechanical gasket materials, basically things that go between bearings on wheels and whatnot, that make it very difficult for the dust to get to the bearings, the delicate parts. These are kind of tortuous paths it has to follow.
And we're fortunate that there's been a couple of lunar simulants that have been modeled on the regolith that was brought by the Apollo astronauts. And so companies and engineers who are looking at wheel design and rover design, they can test out their designs as best as possible with this kind of jagged kind of simulant. I mean, obviously it's not a one-to-one connection. In fact, one of the big mysteries about the permanently shadowed regions, when our L-Cross experiment that we did a decade ago, finding water in Cabeus, it revealed that perhaps the regolith in those permanently shadowed craters are actually different than the regolith that was found on the Apollo sites.
Oh, it's different across the surface.
So there's going to be some learning to be done.
Yeah.
So the engineers will do the best knowledge they have now using a simulant, designing the wheels and the excavation. We're going to have challenges with drills and scoops and all that. The same thing to deal with the beast that is the dust.
Yes.
But we'll overcome those. But we're going to have to get there on the scene at the South Pole and the polar regions and go, that dust is different.
Yeah.
Let's see what we're going to do next time.
All right.
Yeah.
Who knows?
That question foreshadowed my favorite section of the day. You guys described the South Pole as unexplored territory, and you keep referencing that it's really extreme, it's going to be tough. So let's go through some of those specific challenges.
I mean, it's like, wanting to go in the deepest mines on Earth.
Oh, really?
And the deepest undersea exploration. It is
because it's so different from what we're used to, or is it really deep in that
It's
sense?
really deep. So the topography is extreme. It's completely unlike a lot of the topography we saw at Apollo at lower latitudes.
they landed in flat areas.
Okay, right.
Nice, pristine.
That's what I picture the moon as.
And we'll be landing perhaps in areas that are ridges that are sitting on top of a crater that looks down into a 6-kilometer hole.
6 kilometers, that's like 3 miles or
Yeah,
so?
exactly. About 3 miles down. And you can they'll be standing on the edge of these vistas overlooking mountains that are many miles high.
Wow.
Into craters that are 10 miles across and 3 miles deep. And
I never knew it was that extreme.
And then the lighting conditions, because of the low angle of the sun, you can have shadows that are being cast from a ridge of a crater that's hundreds of kilometers away.
Really?
And the shadows will be sweeping across you over timescales of hours. And as we mentioned earlier, when you're in shadow, your temperature drops. And so you're going to be experiencing, of course you're in a suit that's keeping you regulated, but if you think about it, the whole lighting condition, the whole dealing with the swing of temperatures is going to stress out your system. So
your equipment and machinery and everything.
And there are areas where there's areas of this permanent shadow darkness, this permanent darkness, but there's also areas that have what I like to say persistent sunlight. So there are some of these peaks because they're so extreme that no matter what time year it is, it has very often sunlight at it. So it's often at the rims or crests of some of these ridges near these craters. And so those are very attractive for the reasons Kim said, is you won't be getting these deep shadows sweeping across you all that often. And when they do, it might just be for 5, 6, 7 days as opposed to, 3 months, something like that. So these are...
and they're great places to put your power station.
Exactly.
And have some of your infrastructure. Again, it's sort of, if you're going to explore and you're learning about where you're exploring, take advantage of the gifts that were given to you by nature. And also be aware of the dangers,
Of course.
So you keep talking about the poles. We actually have this really cool video showing some light cycles at the moon's south pole.
Exactly right.
Yeah.
So can you tell us what we're seeing? This is
We're seeing
night falling?
Well, what we we started at a low latitudes, looking at the moon as we see the moon, and what you saw was the sun moving across the face of the moon. There is no dark side of the moon. Every side of the moon gets sunlight at some point.
You get 14 days of sunlight, 14 days of darkness.
And we just don't see that.
We just
far
don't see
side.
that because we always see the near side. Now, what's done is this movie's swung down, so you're looking at the south pole of the moon. That crater, nice circular one right in the middle, that's Shackleton crater. It's almost exactly at the south pole of the moon. It is about 15 miles across and about 4 miles deep. And what you see are these shadows that are sweeping across. And it's because, again, as Kimberly explained earlier, the tilt of the moon on its axis is very small. So the sun's always just hugging the horizon, creating these shadows. Okay. And you can see in some of these craters, like the big Shackleton itself and the larger ones just above it, the floors of those craters never get sunlight. They are in permanent shadow.
They just stay dark. You can just stare at a piece of the, pick out a point in the video and look at it, and you can see over the course of the shadow pattern what gets light or not.
Yeah.
And then you also saw there were these rims of the craters that got sunlight all the time, or most of the time they stayed light.
Yeah.
So extreme. So lighting conditions are extreme, topography is extreme, temperatures are extreme. The dust, we sort of know what it's made of, but maybe not.
Right.
We'll see when we get there.
But it could have some other benefits too. We just we haven't explored it. And we haven't explored it with robots yet either. So,
that's
and humans.
Need to get somebody's boots on the ground.
And in general, we see this increase of hydrogen at the poles. And we've seen an increase in hydration of the soils, meaning hydroxyl, OH, or water molecules bound to the soils, even in sunlight. And in increased amounts towards the poles. So just the composition, and even in the sunlight areas, is going to be different from anything we've ever seen before.
Wow.
Yeah.
And that's going to just make the modelers go crazy, because we're going to have a lot of Tony's types of instruments, looking for the water on these scales, and then we're going to try to piece together quite a complex puzzle. But it's an interesting puzzle to have. I mean, we weren't talking about water cycle on the moon. It's only been 10 years. Now, 10 years is not a long time, but it's long enough for to realize that this moon is a place that we have full of things that we don't know what's going on. So.
It's more active than I ever pictured.
It is. It's very active.
And more extreme. I think
Especially at the poles. Kind of picked a better place to go.
Exciting.
Yeah.
Cool.
Speaking of that, you guys don't forget, if you do have any questions, please type them into the Twitch chat. It's twitch.tv/NASA. So we're going to move into our rapid fire section. So Jesta578 wants to know about the nervous instrument. Is it ultrasound, IR, and visual?
It is a little bit of everything. So I always like to say we go in with our eyes wide open for all the reasons Kim just said, because you don't exactly know what you're going to see. So it is actually a combination of near infrared, and for you geeks out there, that's between about 1.2 and 4 microns. Thermal infrared, that's between about 8 and 25 microns. And ultraviolet visible, which is we run about 0.35 to 0.94 microns.
Okay, so it's
it's ultraviolet colors that are below what we can see in terms of our visual spectrum, and energy is beyond what we can see into the thermal infrared.
Okay. And then what Donnie had mentioned is that this is the front end with the cameras, but the infrared is going to be connected to a spectrometer on the back end.
Okay.
Because it's from the spectrometer spreading the light out into different wavelengths, and it's over the infrared that you're going to see the water signature or the hydroxyl signature and the minerals.
Yeah.
And so this is a very, it's a compact instrument with both cameras and thermal sensors to get the temperature, plus the spectrometer to get the amount of
compositions,
what things are made out of.
All right.
So let's see. Dude is Dudette wants to know, is there a sample return plan for lunar water?
Yeah, that's absolutely. They do want to return.
But the question is, will it happen? It will happen with the humans going in 2024, because they're going to bring samples back.
Yes.
Okay.
No worry, we're going to be so excited for that. Question is, will we get a rover to get us a sample return before the humans? Don't know yet. That would be awesome too. But we're certainly going to get something.
We're going to get something, and specifically there's a lot of discussion about cryogenic sampling, because when you sample something that's at minus 230 degrees below centigrade,
think about that.
there's a lot of debate right now whether or not you need to keep it that cold, or do you just need to seal it and make sure you don't lose as it sublimes, as it warms and the ice is sublime.
Yeah, I was on a mission concept for sampling off a comet, and we had that same debate because we're going to bring it back to the Earth. The question is, do you keep it in cryo storage or do you allow it to come up to room temperature? But then you've lost some information. But you're right; they're going to have to solve that issue. I never thought about that. You're right. We're going to bring back our water samples from the moon. We're going to have some.
Keep it cold.
You need a couple cords.
Definitely need a good chiller.
Okay. Bring a cooler.
That's
Bring a cooler. Yeah,
solvable.
as simple as that.
So it looks like Grendian wants to know. He wonders, what does the moon smell like? What does the air smell like on the moon?
Good question.
Well, we don't know, but according to the Apollo tapes, they said it smelled like gunpowder.
Gunpowder.
That was it's reported by several of the astronauts. So my husband and I are geeks. We kind of listen to the audio tapes of all the Apollo missions.
We kind of do that.
It's only appropriate.
In the evening. And more than once they would say it smelled like gunpowder. I have no idea whether that would be true. I mean, it just...
And that's air, to be clear, that's air in the capsule.
That's the air in the capsule. When they got in after their EVAs, this extra vehicle activity, and they're romping around on the surface, and they're coming back in and they're taking off their coats, that's when they smell it. Because... they needed the atmosphere, but they're also in a pure oxygen atmosphere. So I don't know if that changed anything.
Maybe it has something to do with the dust. They think is because again, this dust is very unique. It's never been, as it gets fractured and melted and resolidified by impacts on the surface, it creates what are called very open, active sites on the surfaces that. Again, on Earth, we have all this oxygen around us that reacts very quickly.
I'm just waiting for you to see
on
that
the moon,
reacting.
there's very, very, very little atmosphere. It's called an exosphere, meaning a molecule can leave the surface of the moon and never encounter another molecule as long as it lives.
That's
very
crazy.
sad. It's a lonely life.
Lonely life.
Do they make instruments that measure smell? Or is that just a human thing? Or a dog thing?
There you go.
That's a great question.
That's your newest instrument. There you
Yeah,
go,
it's a
Tony.
smell
Take a
instrument.
pristine sample and then somehow hook up to it some sniffing instrument that will
I guess if
measure.
it knows what molecules are in.
Wait, what a molecule smell like?
Coming off
Well,
of it.
I know there's instruments with the nanotubes that can measure specific chemicals,
Yeah, okay,
right, that as they reach. So it's kind of like a smell.
Is that okay?
But then to extrapolate it to what we would experience.
Yes, that's very subjective. Yeah.
So the dust has these open surfaces and reacts with the oxygen in the
Yeah,
capsule.
that's what I was wondering
saying
whether
make
that
it-
made it.
make
That's
it-
the comment that was made. I
Yeah.
mean, that's our only one data point, right? So we're looking forward to more data
smelling
points.
on the moon.
More smelling the moon.
So Sun Cricket wants to know, will new suits be made specifically for longer stays on the Martian surface? Or, sorry, the moon's surface.
They are working on the next generation suit, and I'm afraid I don't know the name of it, the designation of it, but they are working on a new generation suit that is meant to be more mobile, a lot more mobility to it, and to allow the astronauts to be able to do things like that they couldn't do on Apollo. For example, if you saw an astronaut fall over on Apollo, they would have to do a push-up to get themselves up. They couldn't bend the knees well enough to actually stand. So they'd have to do a push-up a few times until they got enough momentum to get themselves back up. So they are
that. Cool.
And then when they were excavating the soils,
behind.
geek enough, man.
when they were excavating the soils, the fingernails of the astronauts were crushed up against the edges
Oh,
of
yeah.
the gloves,
really?
and they were all bruised and everything. So we want the astronauts on the moon to be very physically active, excavating all this water for us and building habitats and doing that. So the new suits are.
Allow
Very
them to do
different.
that better. Cool.
Yeah.
Here's a good one. Can I jump in with a question?
Go for it,
from
Abby.
Terminus 1961. How do you communicate with a probe down in the crater? What are the challenges?
So this is kind of really interesting point. A dark crater does not mean we can't see into the crater from Earth.
Good point.
So in one instance, you can use what's called direct-to-Earth communications. That's where it's what we did in Apollo.
Or in this case, it's direct to gateway.
Great. Or Earth.
Or Earth. That's true. Or depending on the geometry. Yes.
Exactly.
Sure.
Right. So in some instances, yes, you can see Earth from a PSR, from the floor of a permanently shadowed region or crater. Other instances, you'll be able to look up overhead and see gateway. So you can relay. You can look straight up and talk to a relay satellite or gateway.
Okay.
But they've also talked about having repeaters.
Yeah.
So some of these commercial service providers aren't just talking about providing landed services. I can take you to the moon, but they're also talking about setting up infrastructure on the moon, like
Okay.
Telephone, telecons.
Wi-Fi.
Yeah.
So a lot of
telecons.
Wi-Fi on
the
the moon.
commercial landers that are going actually will communicate with the small rovers and whatnot with Wi-Fi.
Okay.
And they're actually talking about both communication, power, all kinds of relay systems, building infrastructure to actually assist in the exploration and science and build up.
That's cool. Yeah, and that helps me picture better the crater and communicating
Yeah,
straight
good.
up.
I mean,
yeah.
if you're really deep in, you're going to have to go up. But if you're, it depends on where you can put a repeater.
True, true. Cool.
Okay. So I have another question. Cal Coos wants to know, are you going to send rovers to these craters first before we eventually send the next woman or the next person? And if so, when?
We really want to. And we're working on plans along those lines that still are being formulated. So, yes, you need mobility to really understand the distribution of water. And I think everyone appreciates that. So that is one of the higher priorities right now, to understand the resources at the poles, is to get a rover at the poles, at least one. And more, you really probably want more, to start prospecting and characterizing and identifying. And that's the instrument I showed was built specifically to go on a rover just like that.
Oh, yeah.
Yeah. And so hopefully before 2024.
Okay.
But
yeah.
I mean, that's an ideal situation, but there's also alternative. I mean, if we get the human visiting the moon before we get the rovers will be hand in hand. I mean, it doesn't slow down the whole architecture to get humans.
2024 does not depend at all on our better
because
understanding.
wherever the astronauts are going to land is unexplored territory, nonstop. You know,
And they're going to make so many discoveries.
They're going to make so many
there, right?
discoveries, and they're going to be like, we're going to do this slightly different. I mean, this is exactly what happened on Apollo with the 6 landed missions.
Yeah.
Each of them built upon the experience of the prior.
Oh, yeah.
And we all do that in science and in engineering. We learn what works, what doesn't work, and we expand. In fact, perhaps we might have a scenario where the humans get first, and they're going to I want a rover to go over there. Because you know what? I haven't yet developed my harness to do rappelling off of cliff yet. But I know a rover can do it with, some sort of design. And then, a couple years later, I've got my rappelling harness ready to go. So, hey, could be that.
All right. Yeah. Little by
So
little.
we have time for one last question. So XXYHVH wants to know, is radioactivity really a major concern when traveling to and from Earth, and how does this radiation affect your instruments?
It is. It absolutely is, and it needs to be designed into all your considerations, both for the instruments and for humans. And so our instrument uses components and electronic parts that are what was called flight qualified for flight. And what that means is they've undergone testing to show that radiation doesn't affect them.
Okay.
And for electronics, we've been sending probes to Pluto, and the Voyagers have left the solar system.
Long time in space.
So from an electronics point of view, we're kind of smart on making things robust. I mean, the challenges are when you have new materials and really smaller transistors and the like that you'll have to do. But we have facilities here to test them. Okay. So for the biology is the other unknown.
Yeah.
So the biology is the one that we're going to have to be learning and adapting and reacting to and being proactive as we go forward. And also, we're going to be wanting to monitor when the big solar storms come. Right. Our understanding, we have sentinels out in space right now that are monitoring the solar behavior. And whenever we get these solar storms that could, when it happens and our astronauts are on the International Space Station, they go to a certain part of the space station that's more protected, a safer place.
Right.
We're going to have scenarios like that with our humans on the moon as well, and on wherever they are next. So it is a concern, but it's we're going to learn and we're going to adapt and we're going to react and be also preventing things too.
The only thing I'll add is another great use of water is radiation shielding. One of the best radiation shields there is water.
Funny.
So there are discussions about using regolith, but also in the safe room where you really need extra protection, you have a layer of water that you've mined on the moon.
Yeah. Oh, wow.
And then once in other places, like one of the neat discoveries that the Lunar Reconnaissance Orbiter, this is a moon spacecraft in orbit around the moon for the last 10 years, has, uncovered these places that are lava tubes, these underground caverns in the moon.
Ooh.
And they're also places that we have to explore.
Definitely.
They're not quite at the poles, but once we've set up this infrastructure to allow us to go anywhere on the lunar surface,
Yeah.
I bet you an early destination after going to the poles will be go to explore the underground caverns.
Excellent.
That's a safe bet.
And that's also a place for potentially you can take advantage of the what nature gave you as a shield.
Right. Go underground.
Go
underground.
Exactly.
Excellent. Very cool. So maybe
Because there's lava tubes on Mars too.
Oh, that's right.
So you can figure out if you can work this whole thing out on the moon, you've got it sorted for Mars.
Excellent. We got it all figured out.
Yeah.
We have to go and do it.
right.
We're all talk right now. Once we do it,
Right,
then
yeah.
we can say,
Well, we've got
we're ready.
We got 1,656 days to do it.
Yeah, I was just going to say before we have to wind up, we've been talking about all these challenges, and you guys sound confident that we're going to figure it out, but we're going to need a lot of help, right? So there might be people listening who want to get in on that. So do you guys have an answer for what's a good way to prepare to help NASA tackle these challenges down the road? Are there particular majors in college you would do or skills you would develop?
Well, one thing is it's important to note that this isn't going back to put a new footprint on the moon and then come home. It really is to be a sustained presence that is with an open architecture, as Kimberly described. So it's involving everybody from the commercial side to industry to governments, foreign NASA agencies, all NASA agencies. So I really do think we're at the dawn of a new age of exploration. And so the opportunities are going to be incredible and vast in terms of being able to participate not only within a government agency to get into space, but you can now go work at a company and get into space.
Yeah.
And eventually, I do not doubt that there won't only be NASA astronauts. There will be corporate astronauts.
Interesting.
We're going to need people who know how to build things and fix things and improve things
Exactly. Yeah.
and keep an infrastructure going.
All
So
of the above.
basically saying you can do anything.
Just everything from business to engineering to science,
Yeah.
To medicine, to
even the philosophy and the law. I mean, this is opens up an entire new area of international law, interplanetary law
Fascinating.
that we haven't even begun to scratch, really.
Wow.
and it's the
Pretty
basis
exciting.
of becoming a spacefaring civilization.
Yeah.
That's what's next.
Yep.
Exciting.
We're there.
We're there. All right. Well, that is all the time we have for today. So a huge thanks to you guys, our guests, and to everyone who joined us in the Twitch chat with your amazing questions. We will be back on Thursday, July 18th, when we talk about the 50th anniversary of the Apollo moon landing. And then tune in the next day, Friday, July 19th, for a special live broadcast from NASA centers across the country celebrating the Apollo 50th as we go forward to the moon. So for more info on that, go to www.nasa.gov/Apollo50, and we will see you next time. Thanks for watching.